Swayam Prabha. Digital India. Educated India.
Characteristics of these minerals and rock samples, which we discussed earlier in our indoor theory lessons, and today we are going to look at the samples. Okay, so first we are going to begin with minerals, common rock forming minerals, and if you recall from your classroom lessons, we looked at a few rock forming, a few mafic minerals and few felsic minerals. So we begin with the mafic ones, dark colored ones, the ones that we talked about in the class were amphibole, biotite, olivine and plagioclase, and the characteristics that basic characteristics of these minerals are listed in the table there. And then we are going to look at a few felsic minerals, and these are the felsic minerals, and the properties of these minerals are listed in the table there. So we are going to look at these minerals one by one. So let's begin with the mafic minerals. Okay, so here are the common rock forming minerals. We have got 7 of them. Actually, we unfortunately couldn't get a sample of olivine here, but all the rest of the 8 minerals that we talked about, 4 mafic and 4 felsic minerals, they are here. Now the first one that I want to show here is an olivine sample. So the dark colored portions of this particular piece of rock is olivine, and we have got another one here. You can have a look. This is one of the dark colored mafic mineral. Mafic mineral is what we are starting with, and then the second mineral is the is basically biotite mica, and you can see the mica sheets here. Okay, and this is a dark colored mica. It's called biotite. So the color of both amphibole and biotite is black, as you have seen in the table that we presented earlier to summarize the properties. Then we go to plagioclase. This is a sample of plagioclase. You can see that this is basically white colored mineral, and it has got 2 perfect sets of cleavage here, 2 perfect sets of cleavage in this particular case, which both of them have got shiny surface. Now this one, we are going to look at the other properties in detail later on as we continue through the whole demonstration. So the felsic minerals. So we begin with quartz, and the color of this one really. Just first look at the crystal here. This is a perfect quartz crystal. So here what we have got basically conchoidal cleavage. So the cleavage, this is an example of conchoidal, perfect example of conchoidal cleavage. But the color of this particular thing could vary quite a lot. Actually, you could have typically you are going to get white or colorless quartz crystal like this one. But on my right hand here is an example of a little bit more uncommon quartz sample. This one is dark colored, is black quartz, this one. Now we are going to go to muscovite. This is also another mica. dark color, but this one is a light colored mica. You can see characteristics are quite same. It is, both of them are quite flaky. So this one is, on my right hand I am holding muscovite, and the biotite mica that I showed you earlier, part of felsic, as a part of felsic mineral group, that is on my left hand. So you can see and you can compare how they look, right? So then let's move on to other minerals. We have got orthoclase basically. These are some examples of orthoclase. And this type of feldspar, you can just look at, this is the most common, perhaps the most common color of this particular mineral is this one. It looks like meat actually, animal flesh. In color is very similar to animal flesh. And if you contrast, actually this one also has got two sets of cleavage, but you should contrast this one with the earlier sample that we showed for another crystal, another feldspar, the plagioclase feldspar, which is I'm holding on my right hand, and you can see the relative angle between the cleavage, whereas both of them have two sets of perfect cleavage, but the orthoclase feldspar, the planes, the cleavage planes, they are inclined at a much slanting angles in comparison with the angle of cleavage that you normally get in case of plagioclase. Okay, so those are the examples of orthoclase. And now finally we are moving on to pyroxene samples. So these are also actually dark colored samples, and these are the examples, these are some of the examples of pyroxene mineral, and you can have a look at the cleavages. And they're black in color actually. So dark colored mineral by definition is not really mafic. So you could see, you have seen some of the minerals here are dark colored, but they are part of the felsic group. Okay, so that's about all the minerals here. One of the major tools which allows us to differentiate between minerals is the streak and our streak and color. So you saw the color yourself. Now let's look at the streak of some of these minerals. Let's look at some other properties of these minerals. Now, one of the tools which allows us to distinguish between different minerals is streak. That together with the color actually is a very powerful tool which allows us to identify different minerals. So let's look at how we are going to get different streaks. And the streaks, as I mentioned in the class, in the indoor lesson earlier, the streak is not the same as color. So although you could get a mineral which is dark in color, you could for the same mineral you may actually get white colored streak. So let's look at some of the streaks here. Okay, so let's try the pyroxene mineral. So let's start with the pyroxene mineral. So this is the pyroxene mineral that the sample of pyroxene mineral that we have here, which I showed you earlier. So this has got a dark color, as you can see very easily. And this is the streak plate. This is the streak plate used in mineralogy lab. So what we are going to do, we are just going to simply rub this particular mineral on top of the streak plate, and we are going to observe the color of the of what we are going to get on the streak plate. And you can see very easily that the color of what we get on the streak plate is basically, it has got no color. So pyroxene has got black color but colorless streak. But let's try to get the streak of the orthoclase feldspar. So this is the sample of orthoclase feldspar which we saw earlier. This one here, it has got a flesh color. Now if we actually rub it, we get actually white streak. So the previous one, pyroxene, we had a colorless streak. But this powder, actually this is the powder that we got when we rubbed the sample of feldspar. But the streak that we get here is of white color. Okay, so that is the streak for the orthoclase feldspar. The plagioclase feldspar also, if we try rubbing, if you recall from the table that we presented earlier, if we rub the sample on streak plate, we are again going to get white colored streak. Okay. This is about it, about streak. We can try quartz. Let's look at this sample of dark quartz. Let's look at the sample of dark quartz as well as the colorless quartz. Both of them we are going to look at. Let's see what streak we get out of the darker one. So let's rub it, and here what we get, like what we got earlier, we get white colored streak even when the sample is of dark color. Right? Now in this particular case of colorless quartz, again we are going to get, you just look at it, we are going to get the same color streak. Okay, so that's the demonstration on streak, how you determine streak. Now let's get to the next property that was listed in the two tables that I gave you earlier, and that is hardness. So if you recall from what I said in the lesson, hardness is basically whether you can actually scratch one particular mineral with another mineral or not. If you can scratch a mineral with a second mineral, the second mineral is harder than the first mineral. And in this process, actually there is a hardness scale that evolved over in the study of mineralogy, and we call that particular scale as Mohs scale of hardness. Now we are going to look at the minerals that we discussed here, and let's look at, for instance, the list of hardnesses that we listed in the table there, and you can see that the hardness here ranges over quite a bit of, it has got a very large range really. So muscovite has got a hardness of 2 to 2.5, whereas quartz has got a hardness of 7. And there are some intermediate values of hardness, like amphibole has got a hardness of 5 to 6. Pyroxene also has got a hardness of 5 to 6. Now let's let's try to see what we mean by this. So this is the pyroxene sample that we were seeing earlier. So this is the pyroxene sample, and I will try to scratch the pyroxene sample with the sample of quartz. Okay, quartz has got a hardness of 7, whereas pyroxene has got a hardness of 5 to 6. Now let's try to focus on that shiny surface there, and I'm going to put a scratch mark, try to put a scratch mark on that particular shiny surface with quartz, and hopefully we are going to get a scratch mark when we try to do that. And you can see now the scratch mark. So this is the scratch mark that we got from trying to scratch the pyroxene sample with quartz. And since we could put a scratch mark on the pyroxene sample using quartz, and quartz has got a hardness of 7, so we know that pyroxene has got a hardness of less than 7. Okay, now let's try another thing. Plagioclase has got a hardness of 6. So let's see what else we can do here. Muscovite actually has got a hardness of 2.5 to 3. So we should be able to put a scratch mark on muscovite with the sample of pyroxene that we scratched with the quartz specimen. Okay, so let's look at that. So we are going to focus on the shiny surface there, and what we are going to do is difficult, but we are going to try to put a scratch mark on this particular shiny surface using the pyroxene sample, and you can see that this is the scratch mark. You see that this is the scratch mark that we put on the sample of mica using the pyroxene sample. So this particular one here has got a hardness of less than 5, that we can say. This is actually muscovite mica, sample of muscovite mica. Okay, so what else we can try here? We have already discussed about cleavage. I talked about 1 sets of cleavage and 2 sets of cleavage. So this one, let's look at what I mean. So this one here, this is the pyroxene sample once again. So this is an example of perfect cleavage. Okay, this is an example of perfect cleavage, this one. Now quartz on the other hand, this one has got these are not cleavage plane actually. This is an example of there is no cleavage actually in this one, in case of quartz basically. What else? Amphibole sample. In case of amphibole sample also we have got perfect cleavage. We can home on to these dark colored pieces, minerals. So this is also another example of perfect cleavage. Okay, all these things, biotite, amphibole as well as pyroxene has got basically 2 sets of cleavage, but biotite, mica biotite mica and muscovite mica has got one set of cleavage because of the fact that these things are flaky in nature. So I can actually get the flakes out. You can try to focus on that and see the flaky nature of these minerals. You can see that I can easily get the flakes out from these minerals. All right, and the same will be the case in case of muscovite mica as well. And in fact, some of the flakes are coming out from this thing and coming into my hand. Let me see whether I can get some flakes out of this one. So cleavage actually has got, okay, so those are the flakes that are coming out. So you can see that they are really very thin sheets that composes the rock mass. Okay. Okay, now we are going to look at a few samples of common rock types. Let's begin with sedimentary rocks. We are going to look at a few samples of sandstone, shale and limestone. I also included a sample of conglomerate here because that you will see the variety of different types of class or different types of constituents that are present in a mass of conglomerate, because that might be also of interest. Okay, so what we have here, these are actually the cases. What you should really look at is the indication of sedimentation, really. For example, this one here, the big piece here is a sample of limestone, and if you look at it, this is a very heavy one really. If you look at it, you can see the layers in which the calcite mineral was deposited in forming the rock mass. Okay, so the layered structure really is a hallmark of essentially all different types of sedimentary rocks. Okay, so this is actually a piece of limestone. You can see that it is extremely difficult really to distinguish individual grains of this particular type of rock. So it is a fine grained rock. Now here there are a few pieces of sandstone, and sandstone can really vary a lot in terms of the grain size that composes the rock mass, and color also could vary quite a bit. For example, this one is an yellow colored sandstone, and you try to look at the grains of this particular rock mass, and it is really visible to naked eye, and it has got a very rough feeling when you run your finger on top of the rock mass here. And some of these, this one on the other hand, this piece here is pink in color, and you can see the deposition, the signatures of depositional environment here on those lines there. And this particular piece came out of a single bedding of sandstone, so you do not really see those distinct layering that we saw earlier in case of the limestone sample. Now, this pink sample here is much smoother in feel in comparison with this yellow sandstone piece. Now you have got another gray piece of sandstone here. This one is even coarser in feel in comparison with the piece of yellow sandstone, and this one is quite friable actually. So if I rub the surface of this particular sample, then pieces of sand is going to come out of the mass of the sandstone. You can see that I just rubbed my finger on the sandstone, and this is what I got on my hand. And actually sandstone could be quite friable, and it will be very difficult to distinguish if the sandstone is friable and weathered from a mass of sand, from a mass of dense sand. It will be very difficult to distinguish, although there could be some cementation, but in case of friable sandstones, the signature of cementation, actually the effect of cementation, could be quite less. The third sample that we are going to look at, third sample that we have here is a sample of shale, and this is once again what you see here is that layered structure, and this is another one really. You can see the signatures of the depositional environment as well as which is evident from the layered structure that you have here. Now another thing that I want to point out here is that if you recall what we discussed in our classroom lesson earlier on this topic, clay minerals, when they lithify, or rocks form out of clay minerals, then you get what is called claystone or shale. So this is an example of claystone or shale. So here these things are extremely fine in granularity, so individual grains will be impossible to detect by naked eye. You can, if you focus on a small portion of the surface of this rock mass, then you can convince yourself that it is extremely difficult actually to distinguish individual grains of this rock, and that is quite in contrast with what we saw earlier in case of the sandstone. So this is another piece of rock of fine grained, composed basically of fine grained particles. Finally, let's look at, in this group, what we have got. We have got a piece of we have got a couple of pieces of conglomerates, and these are essentially results of cementation of individual pre-existing pieces of rock, and you can see that is very clearly visible here. So for example, that was a pre-existing rock fragment which got cemented by cementitious material, and this cementitious material could be calcareous cement or any other type of cement, silica cement or any other type of cement. And then what forms in the process is a piece of rock, is a mass of rock, and that is called conglomerate. So it is an extremely variable type of rock in terms of grain sizes of the constituents. This is one example, and that is another example of a conglomerate. So let's now move on to the second class of rocks. We are going to start with, we started with sedimentary rocks, and now we are going to move on to igneous rocks. Although I think we should have really started with the igneous rock, but the way these are placed on the table, so it was convenient for me to start with the sedimentary rock. So now let's move on to the igneous rock, and finally we are going to come to the metamorphic rocks. Okay, now we are into igneous rocks. So their origin is basically volcanism, or actually cooling of magma really. So a few common types of igneous rocks are listed here, and in addition to these rocks, we have got an example of volcanic glass as well, obsidian, in this particular group. So just look at the basic characteristics of these types of rocks, and then we are going to take a few samples in order to illustrate all these things. Okay. So let's begin with granite, and what you have got really, this is actually a structure. The structure of granite is called a graphic structure, and this is really an interlocked arrangement of individual grains, individual crystals. And you can see, for instance, there is a crystal there are crystals of feldspar, light colored and fleshy colored really. There are pinkish crystals of feldspar and some dark colored minerals in between, and these crystals really are quite large, and you can see the individual grains in case of granite. So granite is basically an example of coarse grained volcanic rock, and as I explained in the class in one of the earlier lessons, is that because of the fact that granite cools at a much slower rate, the crystals have got a chance of growing to much larger size as opposed to a piece of basalt, the one that I'm holding in my left hand, the dark colored specimen. And you can see that in this particular case the cooling rate was much faster, and as a result individual grains, the crystal growth is much more muted, and the crystals, the individual grains, are much finer. And the other extreme, at the other extreme of this thing, this is an intermediate case really. So this is at one extreme, you could say. At the extreme rapid rate of cooling, what you get is a thing like this. This is a sample of volcanic glass. Okay, so this is actually after the volcanic eruption, the rock forming minerals, they cool at such a fast pace that crystal growth is not possible. So what you get is, instead of a crystalline structure, you get a glass like mass, like the one that I'm holding here on my left arm, the dark colored shiny piece. This type of rock is called obsidian, which is, by the way, not included in the table that we were showing just a little bit back. Okay, so this is an example of obsidian. All right, so you can see, you have seen the structure of a granite. This type of structure is also called an augen type of structure, in which you can, augen means eye basically. So it gives an appearance of an eye really. So there are different between the dark color and the light color. So this is an example of granite, and then this is another one. It's basically a biotite granite, and you can see this is quite a bit different actually. in comparison with the previous example of granite that we were considering. So granite really is not a single type of rock. There could be a wide variety of granite in terms of coarseness of the mineral crystals, as well as in terms of its mineralogical constituent. The one that I am holding in the front towards you, actually towards the camera, is an example of biotite granite. This is a much lighter in appearance in comparison with the previous one, which is a more common variety of granite, pinkish granite, pink granite. And you can see the biotite mineral within the rock mass. This one here that I'm pointing right now is essentially a biotite mineral that we saw earlier. Okay, so these are two samples of granite. This is an example of diorite. So this one here is composed. The light colored background is really you can see that this is also, it has got two colors in it, a light colored background, light colored mineral as well as a dark colored mineral. Typically the light colored mineral is feldspar, and the dark colored mineral in this case is hornblende, and this one here is much lighter in comparison with the granite rock that we were considering earlier. And actually another thing that I want to point out here is that the graininess, I mean the individual grains or individual crystals in this particular case is much finer in comparison with the granite that we saw earlier. And in fact, the second sample of granite was much finer grained than the first sample of granite. So this one here is an example of sienite. Again, we have got feldspar with little or no quartz in this particular case. So this pinkish, the light colored background is once again feldspar, and there are some mafic minerals. You can see there are quite a few mafic minerals in this particular rock mass as well. What else? We have got another piece here, which is a pegmatite. So this one is a pegmatite, and here the structure is again quite similar to what we saw earlier, and here again we have got interlocked crystalline structure in which all the individual crystals they are really interlocked, and here again we have got quite a bit of biotite mica as are evident within the rock here. Okay, so these are basically biotite pieces of biotite mica. Let me see whether you can see if you look at it, you can see that the flake, I could easily deflake this particular mineral, and this is the piece here. Okay, so this pegmatite. And now we are going to move on to metamorphic rocks. Okay, now finally we are into the metamorphic group of rocks, and again we are going to this table here has got a list of few common types of metamorphic rocks, and we are going to look at some of them. Okay, now metamorphic rocks, as we have seen from our earlier lesson, they could form from metamorphism because of pressure increase or because of temperature driven processes from both igneous rocks as well as sedimentary rocks, and we are going to look at some of those rocks. For instance, we saw earlier, I pointed out earlier that marble is a kind of metamorphic rock that forms out of metamorphism of limestone. Similarly, we also saw that gneiss is another type of metamorphic rock that forms out of metamorphism of granite. We are going to look at that in the next little bit. Okay, so these are basically some of the metamorphic rocks. Now, this one here is an example of gneiss, which is listed on the table that we were showing a little bit ago, just a little while ago, and you can see that the layered appearance known as gneissic structure. Really, this is actually goes by the name gneissic structure from this particular sample. And in fact, gneiss is a type of rock that forms out of the metamorphism of granite. So basically, this was the starting point, really. This was the starting point, and you can see that all the individual grains and crystals, they are haphazardly aligned. Now, when this type of rock is subjected to a huge amount of pressure, then minerals tend to get aligned in a particular direction depending on the direction of pressure, and what you get is a gneissic appearance, as is evident from this particular sample here. Okay, you can see the haphazard arrangement of grains, and you can see the ordered appearance that is there on the sample on my left hand, the sample of gneiss, and that is because of the intense pressure that the original rock mass was subjected to, right? So this is gneiss. Okay, and another type of very similar another type of rock of very similar characteristic is granulite, and that is this one here. And so this one, I mean, constitutionally, granulite is very similar to gneiss, but it has got quite a bit of mafic mineral in it. And in fact, the mafic minerals that are abundant in this one, among those is the pyroxene mineral. Otherwise, this particular sample is quite similar in structurally speaking. This is quite similar to the sample of gneiss that we considered earlier. Another difference, actually, slight difference actually, this one is slightly coarse grained. You can see the granularity of this one. It is slightly coarser grained in comparison with the gneiss sample of gneiss that we were looking at earlier. All right, then that is a type of metamorphism we looked at, and now let's look at another metamorphic rock, and this is slate. This one here is slate, and slate, the starting point of slate, you can see the flaky nature of the sample. Okay, thin sheet-like appearance of this sample, and they can very relatively easily, the individual sheets can be separated, although it is going to be a little bit more difficult than deflaking the micas. It's a little bit more difficult, but still the flakes can be relatively easily, they can be separated. So this is, if you recall from what we discussed in the class, slate is a type of rock that arises from metamorphism of shale. Okay, so this is the type of rock that was the beginning of this metamorphic rock. So this is the beginning, and finally what you get is this one here. And this is also more often than not, this is also is because of metamorphism, because of pressure related metamorphism, right? So this is sample of slate. Okay, now another one. This is a piece of marble. It's quite this slightly granular in nature. You can try to focus on it, and it is going to tell you that the structure of this one is granular, in which you can actually see some of the individual grains of calcite. And I will, if you recall from what we discussed earlier, is that marble forms because of metamorphism of limestone. So what we began with is this piece here, the metamorphism of this particular one, which I am holding on my left hand. This is the starting point of this formation of marble. So this is the beginning, and the end product of the metamorphism, the process of metamorphism, is this one. And marble is much more compact generally in comparison with limestone. All right. Another one here is quartzite. So this is actually this is an example of quartzite, and the primary constituent of quartzite is quartz, and quartzite forms from the basically quartzite forms from metamorphism of sandstone. So what you have here is this was a piece of sandstone, pink sandstone, that we looked at earlier. So this was the starting point, and this is the end product of the process of metamorphism. Okay, so what do you this kind of neat, because we actually could compare different types of rocks, metamorphic rocks, and we could see that they are related very closely to a parent rock mass which underwent a certain type of physical process that gave rise to some change in structure, which led to a totally different type of rock, the class of rock called metamorphic rocks, and we saw a certain number of samples of metamorphic rock. Okay, so with that said, actually we are towards the end of the demonstration, in which we looked at a few samples of rock and a few samples of common rock forming minerals. We looked at some of the characteristics, easily determinable characteristics of the minerals, which allows us to roughly identify some of these minerals and distinguish them from other minerals. Okay, so with that we are going to wrap up this demonstration. Okay, then we are at the final little bit of this particular course. In order to wrap up, I'm just going to list some of the mistakes that crept in to our presentations, which you have already looked at, unfortunately, so that you could correct your notes accordingly. I'm going to have a list of acknowledgements, and I'm going to wrap things up with a list of references which you could read at your leisure, and you will find the information in those list of references, useful for improving your understanding about the subject. Okay, you should note these errors that crept in. We noticed these errors as a part of the review process. In lesson 3.3, chemical composition of quartz was indicated as SiO4. It should actually be SiO2. Then in lesson 10.4, I indicated that the rock creep is generally slow, but you should note that the speed of rock creep depends on the stage, really, as to how mature is the process is. So if the rock creep process is at the tertiary stage, then the speed could in fact be quite high. So you should correct your notes from lesson 10.4 to consider this point. Then lesson 10.5, by mistake we indicated that Raipur is a part of Madhya Pradesh, but in fact it is a part of the relatively newly formed Chhattisgarh state. And finally, there were a number of editorial and grammatical errors for which those errors I didn't list here, but I must apologize for those errors in the notes, and I think you would be able to notice those errors and correct your notes because they are quite obvious, although they didn't to my understanding affect the technical content of this particular course. All right, now to the list of acknowledgements. This courseware was prepared in the NPTEL project funded by the MHRD, for which I am grateful. Then external reviewer actually made a very thorough review of this of the contents of the technical contents of this course, and in fact the errors or the mistakes that I listed earlier were largely came out during the review process itself, and I am grateful to the external reviewer for the thorough review. Thirdly, the staff of the Center for Educational Technology, IIT Kharagpur, helped me out with the preparation of this course. They provided an excellent backdrop which made possible this entire development. I am grateful for their help, and they also in fact did comment about the review and the visual appearance of this particular course. That is also very useful in qualitative improvement of this particular courseware. Laboratory staff of the departments of civil and mining engineering and the Department of Geology and Geophysics of IIT Kharagpur provided help with the laboratory and demonstration work, which formed the majority of the last 3 lessons of this particular course. Particularly Professor Saibal Gupta of Department of Geology Geophysics. He was instrumental in developing the lab program of the concerning the mineralogical and petrological assessment of rock and mineral samples. I am grateful for his help. I am also grateful to my students who helped me with various parts of the courseware development, particularly Raghvendra Singh, Amit Gupta, Devaditya Datta, Pavan Kumar, Sanjeev Kumar and Lankesh Laguri. And finally, I need to list some of the general references that might be useful in order to enhance your knowledge regarding engineering geology. Needless to say that the course that I tried to prepare here was by no means complete, so it has to be, the knowledge provided here needs to be supplemented from reading other papers or textbooks. Some of the general textbooks are listed here. The first one, Principles of Engineering Geology. This particular textbook, I found that it contained useful information regarding geohazard, index testing of soil and rock, subsurface investigation of soil and rock sites. It has also got very useful information on remote sensing, applications in engineering geology. The second reference, a textbook of geology. This particular one has very good information on mineralogical regarding mineralogy and petrology of rock and mineral samples. It also has got very useful information regarding geologic map preparation and section preparation and all those stuff which we discussed in the last little bit of this particular course. And thirdly, the book by Praveen Singh, Engineering and General Geology. This also could be a very useful reference. It has got a wealth of information regarding structural geology, regarding faults and folds and other features that we discussed in the early part of this course. It has also got information regarding mineralogy, crystallography, all those details also we discussed in the early part of this course. And you need to discuss the topics with your teachers as the time comes, because the information that is provided here has to be supplemented, as I mentioned earlier, with other sources, because no courseware can be a self-contained repository of all knowledges that there could be on the topics covered. I just wanted to provide you with the glimpse of the subjects that are of general interest in engineering geology. And if you need to interact with me, by all means you should try to contact me through IIT Kharagpur and provide me your comments or questions, and during the interaction I would also be glad to provide you with my inputs on your thoughts or your problems. Thank you very much.